Space is silent. It is a vacuum, devoid of air and atmosphere, where sound waves cannot travel. Unlike on Earth, where sound is carried by vibrating air molecules, space offers no such medium. This vast emptiness stretches out in all directions, creating a profound silence that is both eerie and awe-inspiring. An expanse of emptiness so vast and profound that it challenges our very understanding of existence. The Milky Way, our home galaxy, is just one of billions in the observable universe. Each galaxy contains millions or even billions of stars, yet the space between them is almost entirely empty. This emptiness is not just a void, but a canvas for the cosmic wonders that unfold within it. In the cosmic ballet of stars, planets, and galaxies, there is no accompanying soundtrack. The movements of these celestial bodies are silent, their dance choreographed by the invisible forces of gravity. As we observe the spiral arms of a galaxy rotating, we are reminded of the silent symphony that plays out across the universe. There is only silence, a profound and unending hush that stretches across the universe. This silence is not a void, but a presence, a reminder of the vast distances and the incredible scale of the cosmos. It is a silence that invites contemplation and wonder, urging us to look deeper into the mysteries of the universe. This silence, however, is not an emptiness but a canvas upon which the universe paints its wonders. Nebulae, with their vibrant colors and intricate shapes, are the birthplaces of stars. Galaxy clusters, with their myriad celestial bodies, are the building blocks of the universe. Each of these wonders exists in the silent expanse of space, their beauty undiminished by the lack of sound. It is a silence that speaks volumes about the fundamental laws of physics and the nature of sound itself. Sound requires a medium to travel through, such as air, water, or solid matter. In the vacuum of space, there is no such medium, and so sound cannot propagate. This fundamental truth shapes our understanding of the universe and the way we explore it. To understand why space is silent, we must first journey into the heart of this cosmic vacuum. Imagine traveling through space, moving towards the center of a distant galaxy. As we traverse the vast distances, we encounter the silence that defines the cosmos. This journey helps us appreciate the scale of the universe and the unique conditions that create its silent symphony. The vacuum of space is not an absolute void, but it is incredibly close. When we think of a vacuum, we often imagine a complete absence of anything, a perfect emptiness. However, space is not entirely devoid of matter. There are still particles, albeit in extremely low densities, floating around in the vast expanse. These particles include stray atoms, cosmic dust, and even the occasional molecule. Unlike Earth, with its bustling atmosphere teeming with life-giving gases, space is a stark contrast. Our planet is enveloped in a thick layer of gases, primarily nitrogen and oxygen, which support life and create the weather systems we experience daily. This atmosphere is dense and full of activity, from the microscopic particles that make up the air to the larger phenomena like clouds and storms. Space, on the other hand, is sparsely populated with matter. The distances between objects in space are vast, and the density of particles is incredibly low. In the interstellar medium, the space between stars, there are only about 1 atom per cubic centimeter. This is in stark contrast to the billions of atoms per cubic centimeter in Earth's atmosphere. Vast distances separate stars and planets, leaving a sea of nothingness in between. These immense voids are what makes space so unique and challenging to explore. The sheer emptiness means that there is very little to interact with, making it a silent and desolate place. In this vacuum, there are very few atoms, the building blocks of matter. These atoms are so sparse that they rarely collide with one another, unlike on Earth where collisions between particles are constant. This lack of interaction is one of the reasons why space is so cold and why sound cannot travel through it. On Earth, we are constantly bombarded by trillions of atoms, creating the air we breathe and the pressure we feel. This constant bombardment is what gives us the sensation of touch and allows us to hear sounds. The density of particles in our atmosphere is what makes life possible and comfortable. In space, this density of matter is almost non-existent. An astronaut floating in space is surrounded by a near-perfect vacuum with only a few stray particles drifting by. This isolation is both a challenge and a wonder, as it allows for unique scientific experiments and observations that are impossible on Earth. This lack of matter, this near-perfect vacuum, is the key to understanding the silence of space. Without particles to carry sound waves, space is eerily quiet. This silence is a stark reminder of the vast and empty nature of the cosmos, a place where the usual rules of our everyday world do not apply. The vacuum of space is a fascinating and humbling aspect of our universe, highlighting the delicate balance between matter and emptiness. Sound, unlike light, is not a wave that can travel through the vacuum of space. While light waves or electromagnetic waves can move through the emptiness of space, sound waves require a medium to carry their vibrations. This fundamental difference is why we can see the light from distant stars but cannot hear any sounds from space. Sound is a mechanical wave, which means it needs a medium to travel. This medium can be a gas, a liquid, or a solid. When you hear music from a speaker, the sound waves are traveling through the air, which acts as the medium. The vibrations from the speaker create pressure waves that move through the air, eventually reaching your ears. Imagine a pebble dropped into a pond. The moment the pebble hits the water, it creates ripples that spread outwards in concentric circles. These ripples are a visual representation of how sound waves propagate through a medium. The ripples that spread outwards are analogous to sound waves. Just as the ripples move through the water, sound waves move through the air, water, or any other medium. The energy from the initial disturbance, whether it's a pebble or a sound source, is transferred through the medium, creating waves that travel outward. The water acts as the medium through which the wave travels. In the case of sound, the medium could be air, water, or even a solid material like metal or wood. The properties of the medium, such as its density and elasticity, affect how quickly and efficiently the sound waves travel. Similarly, sound needs a medium like air, water, or even solids to propagate. In air, sound travels at approximately 343 meters per second, but it can travel faster in water and even faster in solids. This is because the molecules in liquids and solids are closer together, allowing the sound waves to transfer energy more efficiently. Without a medium, there is nothing for sound waves to vibrate, no way for them to travel from one point to another. This is why space is eerily silent. Even if an explosion were to occur in space, you wouldn't hear it because there is no air or other medium to carry the sound waves. The vast expanse of the universe remains a silent void, emphasizing the crucial role that a medium plays in the propagation of sound. Section 4. Earthly echoes: how sound travels in our atmosphere. On Earth, sound travels through the air as vibrations. When we speak, our vocal cords vibrate, causing the air molecules around them to vibrate as well. These vibrations then travel outwards like ripples in a pond until they reach our ears, where they are interpreted as sound. The denser the medium, the faster sound travels. This is why sound travels faster in water than in air. In the near-perfect vacuum of space, however, there is no medium for sound to travel through. Section 5. Bridging the interstellar silence: radio waves to the rescue. If space is silent, how then do astronauts communicate with each other and with mission control back on Earth? The answer lies in a different kind of wave: electromagnetic waves. Radio waves, a type of electromagnetic wave, are used for communication in space. Unlike sound waves, radio waves do not need a medium to travel. They can travel through the vacuum of space at the speed of light, enabling communication across vast cosmic distances. Section 6. Houston, we have a conversation, a historical perspective. The use of radio waves for space communication has been a cornerstone of space exploration since its inception. One of the most iconic examples of this is the Apollo 11 mission, which landed the first humans on the moon in 1969. Throughout their journey, the astronauts communicated with mission control in Houston using radio waves. These communications, broadcast around the world, allowed millions to share in the awe and wonder of this historic event. Section 7. The sound of silence, a source of awe and wonder. The silence of space, while initially disconcerting, is ultimately a source of profound awe and wonder. It reminds us of the vastness and emptiness of the cosmos, and of the preciousness of our own planet with its bustling atmosphere and symphony of sounds. As we continue to explore the universe, this silence serves as a constant companion, a reminder of the mysteries that lie beyond our world and the fundamental laws that govern our cosmos.